So in example 1 we have the limit as x approaches 4 of the function x minus 4 divided by x squared minus 3x minus 4. And what we're trying to find is the function values that this approaches, not necessarily what it is at 4, but what it approaches when my x values get closer and closer to 4 from both sides. So I've went ahead and found these values, and from left to right, if I plug in a 3.9, I get 0.2041, and then if I plug in a 0.399, 0.2004, then 0.2000, and if I plug in a 4, I end up getting 0 divided by 0, which is not a defined number. So that is, there's actually a hole there on the graph. So there's no function value there. When I plug in 4.001, I end up with 0.1999, then 0.1996, and then 0.1960. Alright, so as we get closer, as our x values get closer and closer to 4 from the left side, that's what we call the limit as x approaches 4 from the left side of this function. And it appears as that is going to be 0.2. Those values get closer and closer and closer to 0.2. I'm going to go ahead and delete those trailing zeros. And then same thing from the right hand side, or from the positive side, which would be our limit as x approaches 4 from the positive side of this function, is also appearing to approach 0.2, getting closer and closer and closer to 2, which means that, see, because these are equal, that would be the same as the limit as x approaches 4 in general, which would also be 2. Last thing to think about in this example is how do we get these x values. So basically in the middle here, this 4, that's where you're going to put whatever your limit is approaching. So in this case, x equals 4. And then with increasing being spread out, we find values that are close to 4 and then a little bit farther as you go farther away. And same thing from the left side. So at this point, pause the video and try examples 2 and 3. And then when you're finished, go ahead and unpause, and we will show you the answers to those, and you can check your work. So, alright, so now that we're back, example 2, same idea. We have these function values from the left and the right. These guys are getting closer, it looks like, to this value of 0.2041, and then these guys appear to be getting closer to this value, 0.2041. So it looks like the limit as x approaches 0 from the negative side is going to be the same as the limit as x approaches 0 from the positive side, which that means that the limit as x approaches 0 in general, they're all going to be this 0.2041. Okay, example 3, a little bit different. This is an example where you have absolute value of x minus 2 divided by x minus 2. So let's start by plugging in an a 2, because that's where our limit is getting closer to. So as you can see, when I plug in a 2, I end up with 0 over 0. So let's say f of 2 equals 0 divided by 0, which is why we got this undefined. Let's plug in any value that's less than that. You're going to end up with the same number divided by the same number, but one's going to be positive and one's going to be negative, which is why all of these values are negative 1. And then same thing on this side, all of these values are positive 1. So graphically you can see that to the left they're all negative 1. So the limit as x approaches 2 from the negative side will be negative 1. The limit as x approaches 2 from the positive side of f of x will be positive 1. And because those are not the same, that means that the limit as x approaches 2 does not exist. There is no limit.